Hello, Proviso math students, and today we're going to be talking about how to work with complementary and supplementary angles. This is Mr. Appleman, and let's get started. So these are going to be the first set of notes on angle relationships, talking about complementary and supplementary. We're going to start off with some just basics on how to name angles. The first thing we're going to look at is this angle here, and we're going to talk about 3 ways to name this angle. The first way is the most obvious way, which is where the vertex is. Now the vertex is where this actual angle occurs right here, and the point at which that occurs can be used as a name typically. So you could call that angle R. The catch is it's math. We don't want to have to write everything out, so we use symbols instead of words. So for the word angle, we use the angle symbol, which looks like a less than symbol, just a little flatter, and then the letter R. So that's angle R. There are other ways to name it though. So we're going to talk about why this is important in a minute, but you can also name it with all 3 points that are placed on it. Now there's technically more than just 3, but you only need 3. You need 1 point on one of the rays, 1 point on the other ray, and the actual vertex itself. So let's start off with that. The order this one goes in left to right is QRS. So I would call this angle QRS. Notice that the actual vertex is in the middle right here. You don't need to underline it every time. I'm just highlighting that. So you've got the angle symbol, you got QRS, or you can name it angle SRQ. It has to go from one side to the other with the vertex in the middle. So for this next one, I'm going to recommend that you actually pause it after you read the problem. It says draw and label and name an angle on your own. Be sure to name it 3 ways. I'm actually going to show you a 4th way as well. So pause it. Okay, so depending on how you did it, may look the same as mine, may look different. It's hard to say. But generally, I'm just going to do a generic little angle. And I'm going to put a point on the ends somewhere on there. Put the arrows, because all angles go that way. And put the actual arc where the angle is. And I'm just going to label this A, B, and C. I'm also going to put a number 3 here. And I do that just because it could be any angled number you want. But the way I'm going to name this is first angle and then where the vertex is. That's the obvious one we were talking about before. So angle B. I could also name it from the 3 angles, the 3 points that connect to make this angle. And that is from point A to point B to point C. Remember, the important thing is that the point B is in the middle, because I could also go the other direction, which is angle CBA. Now, where I'm going to name it a 4th way, that may or may not be how you've seen it before, is if you ever have a number that is actually inside of it, and it is not a degree, so it's not like 3 degrees or 50 degrees, it's just a number, then you can actually call it angle 3. And you will see that from time to time. Okay, so what we have here next is actually something that's not on your note sheet. It's still very relevant. It's something I would recommend you add it somewhere, either on a separate sheet or on the sheet itself, because it deals with something called adjacent angles, which is when you have more than one angle connected together. And the reason why I'm bringing this up is because it brings up a very important concept of naming angles. So it says to name the angle indicated in as many ways as possible. We're referring to the angle indicated by this arrow, meaning this actual angle in this space. That's why it's marked the way it is. So let's start off with what the most obvious answer you're thinking, which is probably angle O. But I'm going to stop that right there. I'm going to say, no, that's not the angle name. And the reason why is because when you talk about naming something, it has to be unique and specific. When someone calls your name and someone else has the same name as you, you tend to have a last name as well that you can differentiate between the 2 of you. If I said angle O, would I be referring to the one that's indicated or the one next to it? Or even more appropriately, the whole thing? And the answer is yes to all 3. In other words, angle O is not specific enough to actually indicate which angle I'm talking about. So that is not a name for this angle. Instead, you could still name it based on the points that are on it that come from this ray and this ray. Those points are angle A, O, and B. Again, the O has to still be in the middle. You cannot name this ABO or BAO or anything like that. It can be named BOA on the other hand, even though I almost said it couldn't. It also has a number inside of it that's not a degree, doesn't have the degree symbol, so you could call this angle 2. So you could name this particular angle any way you wanted with AOB, BOA, or angle 2, but you cannot name it angle O because you could be referring to either one of those, and it's not specific enough. All right, so here we're at the practice section, and here I want you to try these on your own. So pause the video, give it a shot. Worst case scenario, you erase or scratch out, and then go with what the correct answers are. Okay, assuming you paused, here is what we're looking at here. The first one has angles with points R, Q, and P. The vertex is at Q, so it's going to be either named angle RQP, angle PQR. Now technically you could also name this one angle Q. I know I named it 3 ways. You only needed to name it twice. Whichever 2. If you chose any 2 of those, you're good. With number 2, same idea. Could be angle IHG, could be angle GHI, or it could be angle I. Did you get them right? Hopefully you got those right, but if not, that's okay. Hopefully you learned something out of it. All right, so now we're going to look at some new vocabulary, and this is where the focus of this set of notes is really coming down to, which is the concept of supplementary angles and complementary angles. Supplementary angles are any angles, and there could be 2 or more, that add / sum to 180 degrees. So examples could be a couple of things that happen. You could have an angle that is 80 degrees, and there's an angle that is 100 degrees. Those 2 are what we would call supplementary. Now notice they're not connected, they are separate. So supplementary angles can be separate. They can also be connected. So if this is 75 degrees, this is 105 degrees. There's another example of what supplementary angles look like. So they could either be connected or disconnected, does not matter. Complementary angles, on the other hand, are angles that add or sum to 90 degrees. So some examples of that would be something like if I have a 30-degree angle and a corresponding 60-degree angle. 30 plus 60 is 90. So those are complementary angles. And again, notice they're separate, but you can connect them. When you add 2 angles that are adjacent and they end up being complementary, they end up forming something called a right angle, which is this box that they put inside of an angle. So maybe this is 40 degrees and this is 50 degrees, but together they form this 90-degree angle, which is this symbol right here. That indicates 90 degrees. So at this point, it's just a bunch of things for you to try. Pause this section and then go ahead and give it a shot and then see how things worked out. So, okay, assuming you paused, for it to be a supplement, that means that the angle given and the angle that we're looking for has to add up to 180. So I'm going to take 180 and I'm going to subtract the 115. That's going to tell me it's 65 degrees. The complement, on the other hand, says it has to add up to 90. So I'm going to take 90 minus the 115. Well, guess what? That gives me a negative angle. In those cases, there isn't one. So if the angle is already bigger than 90 degrees, it can't have a complement. It's not possible. Looking at angle 2, you have 85 degrees. So I'm going to take 180 minus the 85. Looking at this guy now. And if I subtract those 2, I end up with 95 degrees. for my supplement, or here I take 90 minus the 85, which gives me a 5 degree. Identifying the angles as supplementary or complementary and then solving for x. So because these two angles form what we call a straight line, though that is a redundant statement, all lines are straight, but when two adjacent angles form this perfect line with a sort of piece between them like that, that means that they are supplementary, and they're going to add up to 180 degrees. That means I'm going to take 180 minus 85, which will give me 95, kind of like how I did before. So 95 degrees. Notice that I'm not actually filling in the complementary part because it's not complementary. I just marked the one that it is. Identify the angles as supplementary or complementary and solve. So same idea. So what we're really focusing on here is this pair. We don't really have, there's actually a way to figure out this angle right here, but we're not going to deal with it. We're just going to focus on those two. And if you notice, it has that right angle symbol in there, that makes that complementary. And so by definition, those two angles have to add up to 90. So I'm going to subtract the 32 that they gave us, and that's going to give me 58. So the angle is 58 degrees. Now I have a slightly different looking situation, but if you notice this angle that has the variables in it and this angle that does connect, and when they connect, they form this half circle, or this line, if you will. It's a perfect line. That makes them linear. That means that they're supplementary. So this is a supplementary pair. And when they're supplementary, that means that together they have to add up to 180. Now a problem like this requires a little bit of algebra behind it. So I'm going to take the first angle, the 2x plus 20, and I'm going to add it to the second angle, the x minus 5, and that should equal 180. Basically, I'm just going to combine like terms from this group to this group. They're on the same side of the equal sign. So 2x and 1x add to be 3x, and 20 and plus negative 5 is a positive 15. That equals 180. I solve by subtracting 15 from both sides. That gives me 3x equals 165. I divide by 3, and that gives me x equals 55. That is not the angle measure, that is simply what x is, and that's all it asked for. It said solve for the value of x. Same kind of situation, but again, this time what we have is we have a right angle, which means they are complementary. And if they are complementary, that means that they have to add up to 90 degrees. So I'm going to take that 2x plus 25 as the first angle, add it to the 5x minus 18 from the second angle, and set it equal to 90. The 2x and the 5x add to be 7x. The 25 and the negative 18 add to be a positive 7. And so what I end up with is I'm going to subtract 7 from both sides, which gives me 7x equals 83. I'm then going to divide by 7. Now 83 does not divide evenly by 7. In this case, just leave it as a fraction. If we had to do something with it, we would turn it into a decimal, but because we don't have to do anything with it, just leave it as a fraction.